Hello, good morning. Welcome to our presentation of our team of the final project. The engineering world is quite complex, and our duty as engineers is to learn as much information as possible. That is why, for the last 5 weeks, we have learned concepts of electromagnetism, just for building a homemade motor and to calculate its torque.
Experimental theory. Well, the induced electromotive force is a process in which a current can be induced by a charge in the magnetic field. And the electromotive force refers to a potential difference across the discharge loop. Here we have an example of how it works. The fundamental laws describing the electromagnetic induction are going to be the Faraday's and the Lenz's law. The Faraday law relates the rate of change of the magnetic flux that passes through a loop with the magnitude of the electromotive force induced in the loop. And the Lenz's law tells us which direction the current flows and that each magnetic field generated by an induced current goes to the opposite direction. And here is the Faraday's law, and this minus sign is because of the Lenz's law. Here we have the data we use to our experiment. And well, the experimental in here we have all the materials. Piece of wood in approximately 16 by 11 centimeters. Then you will any circular type shape object in which you will need to roll up the insulated copper wire in order to obtain the circular form. Leave some wire from the two sides for the paper clips. After this, take a pair of scissors and file the insulator part of the excess part of the cable. Grab the two paper clips and make structures to hold the copper loop. Take the paper holders, then switch the battery holder, then glue it to the piece of wood in the following order. At the back of the wood, glue the battery holder. On the opposite side, glue the paperclip holder and the switch between the two objects. Then weld the three objects together. From the battery holder, grab the negative part and fuse it to the paperclip holder. Then the positive cable of the holder, bond it on the part of the switch. Afterwards, take the other leg of the switch and weld the cable from the leg to the other paper clip holder. Finally, grab the loop and put it the holders. They place the magnets underneath and they glue them to the wood. After this, place the batteries on the battery holders and turn it on. Here we have some photos and videos of our projects.
Okay, now we're going to see about the experimental results. First of all, we use the formula that is shown, that is torque is equal to horsepower times a constant, and this is divided by the RPM. We use this formula because this formula is how to obtain the torque of an electric motor, and we use this formula because as a team, we think that this formula uses some of the values that are relevant, such as RPM and horsepower, that are relevant to the project. So how we calculated or measure the measurements. First of all, the voltage, it was using a multimeter. It was really simple, just to put in the two sticks and measuring it. The current was searched on the web, as you saw on the videos. Um, we use different type of batteries, so it was to we needed to search the current on internet. Then the resistance was by using Ohm's law. As you know, when we have the voltage and the current, we only need to do simple math operations to obtain it. But also, in order to prove in order to confirm that this data was correct, we use the table that you saw earlier on the presentation, that were the cable of the thickness and the resistance per 100 meters and per AWG units, and also the factor resistance of the copper and the wire, the copper and the aluminum, because the cables that were shown on the project were, one of them was of copper and the other were of aluminum. So when we calculated in this way the resistance, we got the same result as the one that we obtained on Ohm's law. So we can confirm that the current, most importantly, is correct. Then the RPM was measured by using a multimeter. How is this possible? The multimeter has a function of measuring frequency in hertz. So we measure the frequency in hertz of the motor, and we obtain it on about 12 and 18, like something like that. And in order to transform it to RPM, we only multiply these values, the hertz, by 60. So in that way, we obtain the RPM. Then the power. For the part of the power and the horsepower, sadly, we don't have the instruments to measure them correctly. So we only made mathematical procedures to obtain these measurements. So for the power, it was only by multiplying the current and the voltage that we know that is correct from the Ohm's law. And then the horsepower, it was by, when we have the power, we only divide it by 746 watts. That is the equivalent, and then we obtain the horsepower. And finally, with all this data, we can obtain the torque, that is of for the motor 0.05 pound-feet. So we have here a table of data table that summarizes all of what I just said, and it's the voltage, the current, the resistance, the frequency, the RPM. You can see that the frequency and the RPM is a range. This is because there are some of it was higher, some of the measurements were higher, and some of them were lower. So we respect this, and we have the range of the frequency and also range of the RPM. The other data are just a simple number.
Now let's talk about the analytical results. Well, the experimental analysis part consisted in doing a code in MATLAB. This code, the one we are seeing right now, is a reflection of the torque and the time. We achieved it by using the formulas we have previously discussed during this presentation, and well, that's the code itself. For you to know, we plotted the results of this code, and in this graph we can see the torque reflected against the time. As we can see, the torque decreases due to the fact that the battery charge decreases as well as time passes on. The second code we did was a time voltage code. Using the same equations we used for the past code, we achieved code that expressed the voltage of the battery towards the time. Here we can see that the voltage of the battery decreases in an exponential way as time passes by.
For the last part, we have the discussion of the results. We're now comparing the experimental results versus analytical results. In the experimental, the torque that we obtained was of 0.05 pound-feet. And the analytical part, we got 0.065 pound-feet. This is a mistake of 0.01. With the analytical part, we can predict how the motor is going to behave over time. Physically, we are aware that the torque must decrease. This is because the cells must be discharged. With the MATLAB algorithm, we can know how much is changing and how it will behave. So, in conclusion, we must use the two methods in order to predict the physical phenomena. If there were zero experimental values, we will fail to predict the events of the motor. And without the algorithm, it will be very challenging to predict how it's going to behave in the real world. So, this is the end of the presentation. Thank you for listening, and these are the references of the project.
Thank you.